All right, so the plan segment gets a bit trickier, but it's not anything too crazy. So what are we looking for? Well, first off, it's clear that this is matched data, right? Or paired data. So we'll go ahead and make a note of that. So we'll say the data is paired. What else is it? 10 men volunteered to test the exercise device. So volunteer, it's not the best, but we can assume that it's random enough. It's not truly random, but you can't exactly force people to test a device. So we can assume, at least we can assume that the data is, or the men are independent from each other. So that should be good enough. The differences are independent from one another, and the volunteers, and we can assume the volunteers were sufficient random. So there you go. It's just random dudes, right? Now the normal condition, there's nothing in here that suggests that this distribution would be normal. And there usually won't be for problems like this. If you get a problem where it's a paired data problem and it states specifically that the differences are normally distributed, then that's very good, because normally that won't happen. So what we have to do is we have to go to our calculator and say, okay, well, and I've already input the data. What we have to do is put it into a listen spreadsheet, and then we have to check to see if there are any outliers, right? If there are any outliers, then we are not able to proceed with the test. In case you forgot how to do that, essentially you just make a box and whisker plot using your data. So menu, oh, I'm sorry, that's not how you do it. Control, doc, and then, oh, what's happening? It's not working. So we push control, doc, 5 to get this. We sort our data. Looks like this guy could be an outlier. Let's find out. Change the plot type to a box and whisker plot. And no, it's not an outlier. It's close, but it's not an outlier, thankfully. So in that case, what we'll do, where's the page? We'll go back here and say the dot plot, I'm sorry, the box plot for the differences has no outlier. Therefore, we can assume normality. All right, so then what we'll do is say, okay, because of these conditions, we will perform a t-test. Sorry. Yeah, a t-test, or a matched paired t-test. There we go. For the differences between we'll call it mean A minus mean B. I know there's a lot. Bear with me. Mean A minus mean B. With the null hypothesis that mean A minus, why did I write out minus? Minus mean B equals 0, because we are assuming that there's no difference. And then that is compared against the alternative hypothesis, that in this case, we're doing after minus before. So if it did reduce it, then we're looking for a negative value, right? So the alternative hypothesis will be that the mean of the after minus the mean of before is a number less than 0. And it's also important to note that we are going to use a significance level. It doesn't specify, so we'll say with significance level alpha equals 0.05.